Hi, sixth graders. This is Mrs. Gall. Today we're going to talk through angle relationships. Open your notebook to a fresh page, get this title at the top, and press play when you're ready to continue. When a set of lines intersect and we see this 90-degree angle created, we call those perpendicular lines. When we have a set of parallel lines, that means they're running on and will not touch at any point in time. And we see this line that goes through them, we call it a transversal line. All of these pieces are going to come into play today as we talk through different relationships with angles. Go ahead and write vertical angles down in your notebook. Vertical angles are when two opposite angles formed by the same two intersecting lines occur. If I'm looking at opposite lines or opposite angles, I'm looking for a set of angles that are directly across from one another with these intersected lines. 1 and 2 are vertical angles. That means they share the same angle measurement. So angle 1 is the same, it's congruent to angle 2. If angle 1 was 105 degrees, that means angle 2 would be 105 degrees because they are vertical angles. What other set of vertical angles do you see in that picture? 3 and 4. So the measurement of angle 3 is going to be congruent to the measure of angle 4. Our next set of relationships is adjacent angles. Adjacent angles are two angles that have the same vertex between them and share a side. If we're looking at our example, the measure of angle ABC, so this large angle, is going to be the measure of angle 5 plus the measure of angle 6. Complementary angles are two angles that have a sum of 90 degrees. 7 and 8 are going to total to equal 90. Measure of angle 7 plus measure of angle 8 equals 90 degrees. So you can use that to help you. If you know one angle is worth 45 degrees, then you know the other angle must be 45 to get your total to 90. Supplementary angles are two angles that have a sum of 180 degrees. They form a straight line. So the measure of angle 9 plus the measure of angle 10 must be 180. Press pause if you need more time on this slide. Press play when you're ready to continue. Alternate interior angles. This is when pairs of angles on opposite sides of the transversal and inside the parallel lines occur. Alternate means on opposite sides. Interior means inside the parallel lines. So let's look at a set here. We're inside the parallel lines. I see a 4. On the alternate side of the transversal line, but still on the inside of our parallel lines, is a 6. So that means 4 and 6 are alternate interior and they share the same angle measurement. Whatever angle 4 is, that will be the same as angle 6. There's one other set of alternate interior. Can you spot it? Angle 3 is on the inside of our parallel lines, and if we look at the alternate interior on the other side but still inside the parallel lines is a 5. So angle 5 and angle 3 share the same measurement. We have alternate interior angles, and we also have alternate exterior angles. This is pairs of angles on opposite sides of the transversal outside of the parallel lines. Let's look at an example. So we want to be on the outside of the parallel lines. I see a 3. And then on the other side of the other parallel line, but on the opposite side, is a 7. So the measure of angle 1 is the same as the measure of angle 7. Same thing with our other pair. We have a 2 on the outside of this parallel line. If I go to the other side of the parallel line and look on the outside, I see an 8. That is another pair of alternate exterior angles, and those two angles share the same measurement. My last angle relationship are corresponding angles. These are pairs of angles in the same position on the parallel lines in relation to the transversal. We're looking for angles that just sit in the same spot. So if I'm looking at 1, it sits on top of this parallel line to the left of the transversal. So if I go down to my second parallel line and look to the left of the transversal, I see a 5. So 1 and 5 are corresponding angles because they sit at the same point. So we could say 1 and 5 are the same measurement. There are many sets of corresponding angles here. Can you spot another set? You could say 3 and 7. They both sit below the parallel lines to the right of the transversal, so that they share the same angle measurement. Can you spot another set of corresponding angles? You could say 2 and 6. They both sit on top of the parallel line to the right of the transversal. And what's my last set? 4 and 8. They both sit below the parallel lines to the left of the transversal. Let's look at this example and see if we can find the measurement of the missing angles based off of the relationships that we're being asked about. So what's the relationship between 4 and 8? If I look at 4 and 8, they are not both on the same side of the parallel. They both just sit on top of the parallel. And it looks like they are corresponding because they're sitting in the same spot on the parallel lines, on top and then to the right. So those are corresponding. I'm just going to abbreviate for time. What's the relationship between angle 3 and angle 8? If I search for angle 3 and 8, I see that they are both on the inside of the parallel lines, but on opposite sides. So we call that alternate interior because they're inside the parallel lines, but on alternate sides. What about 1 and 6? 1 is here, 6 is here. They're on the alternate sides, exterior of the parallel lines. So that would be an alternate exterior relationship. 7 and 8. 7 and 8 are directly vertical to one another, so that would be a vertical relationship. 2 and 3. 2 and 3 are right next to each other. They are supplementary because they form that 180-degree line. Together, they would total 180 degrees. 3 and 7. 3 and 7 sit at the same spot in relationship to the parallel lines and the transversal, so that's another set of corresponding. If the measure of angle 7 is 60 degrees, what is the measurement of all other angles? Once you know that angle 7 is 60 degrees, you can use your connection between all the other angles to figure out those missing pieces. So if 7 is 60, remember that vertical angles are the same measurement, so 8 must be 60 degrees. There are so many ways to connect these here. I could now use 8's knowledge now that I know that 60 degrees and connect that with my 5 next door. I know that these are supplementary, so their total should be 180. So 60 to get up to 180, that would be 120 degrees for angle 5. Now I see that 5 is vertical to 6, so I could say that those are the same measurement, or I could go back and use my knowledge about supplementary and go back to my 7 and use that 60 there. So we're going to see two angle measurements, the starting angle measurement and then that other piece that got us up to 180. Now we need to find a way to figure out 1 through 4 over here. I can use my alternate interior or my corresponding relationships. 4 and 8 are corresponding, so they have the same angle measurement. They sit in the same spot. So 4 has to also be 60 degrees. I could say 3 is 60 degrees because it's alternate interior to 8. Let's see, what other ones haven't I used yet? Ooh, alternate exterior is a good relationship to use. So 6 and 1 are alternate exterior because they're on opposite sides on the outside, so they share the same value. And then we could just say that 1 is vertical to 2, so 2 is also 120 degrees. So those are just some of the ways that we can connect our angles to share those different relationships. Let's try one real world. I had one bench question that I wanted to ask you. Sorry, it's at the very end. We already did a lot of this. Here it is. The balance beam is parallel to the floor. What is the relationship between X and Y? X and Y are alternate interior. Do you see that? They're both on the inside of these two parallel lines on opposite sides of that transversal. If Y is 117 degrees, what must X be? It must be the same, also 117 degrees. All right, you guys, that's all I have for you today. Check in with your teacher if you have any questions.